Hello there, and welcome to the Sleepy Space Channel. There is no edge to the universe that anyone has ever found. Each wall we once thought was the farthest turned out to be the inner room of something larger. A dome of stars became one galaxy, and one galaxy became trillions. Part of this is that our instruments keep reaching farther, turning faint smudges into whole galaxies. And part is stranger still, because space itself is stretching, carrying the galaxies apart faster and faster, so the universe is larger now than when this sentence began. The most honest answer to how big it all is turns out not to be a number, but a direction, outward and still moving. Tonight we follow it slowly, from this small world to the edge of all that can be seen, and gently past it. If you find these quiet journeys through the universe worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next couple of hours, none of this is something you need to hold. The universe will go on growing without any help from you tonight. Settle in and let yourself grow heavy. Let your shoulders soften. Let your breathing slow. Let the day fade quietly away. Let's begin. Part 1. The number that will not hold still. There is one question in all of astronomy whose answer has never stopped changing. It is the simplest question a person can ask while looking up at night. How big is the universe? The strange thing is not that the answer is large. The strange thing is that the answer keeps growing, again and again, with every generation that dares to measure it. Every age of astronomers believed, for a while, that it had found the edge. Each time, the edge turned out to be a wall inside something larger. The sphere of stars became one galaxy among many. One galaxy became a few. A few became hundreds of billions. And the space between them grew with every step, until the human mind could no longer hold the whole picture at once. The size of the universe is the one measurement in science that has only ever moved in a single direction. It has only ever grown. No careful look has ever made the cosmos smaller than we thought. Every honest revision has carried the number outward, into more distance, more galaxies, more time, more room. Tonight we follow that growing all the way out. We begin on the ground beneath you with the slow, steady ruler of light, and we climb outward, one rung at a time, until we reach the edge of everything our telescopes can see. And then, gently, we step past even that. Along the way, two different kinds of growing run side by side. The first is the growing of our reach. Each time our instruments improve, the known universe gets larger, not because anything has moved, but because we can finally see what was always there. The faint becomes visible. The blur becomes a galaxy. The frontier retreats before our eyes. The second kind of growing is stranger and quieter. Space itself is stretching. The distance between distant galaxies increases with every passing second. The stretching is speeding up, and because of it, the part of the cosmos we can see is far larger than its own age would suggest. The universe is not only large, it is enlarging, right now, as you listen. What we call the edge of the universe is not really an edge at all. It is a horizon, set by the age of the light that reaches us, not by any wall in the cosmos. Beyond it, the universe almost certainly continues, far past anything we will ever observe, perhaps without any end. So the honest answer to how big the universe is turns out not to be a number. It is a direction, larger than the last answer, larger than it was a moment ago, and still, even now, being measured. That is not a gap in our knowledge to be uneasy about. By the end of tonight, it may feel like the most restful fact there is. Consider how strange this is, compared with almost everything else we measure. The height of a mountain does not keep rising each time we survey it. The distance across an ocean does not double with every better map. But the universe has done exactly that, over and over, swelling in our understanding by factors of millions, with no final figure ever reached. There was a time, not so long ago in the long story of our species, when the heavens were thought to be a fixed dome of fixed stars, close overhead, turning gently each night. The whole of creation could be imagined as a single great room, with the earth at its floor and the stars set into its ceiling like lamps. Then the room grew. The stars were found to be other suns, scattered through a depth of space the eye could not fathom. The single room became a galaxy. The galaxy became one of countless galaxies, and the depth between them opened into a gulf so wide that light itself, for all its speed, takes billions of years to cross it. At every stage, the people who lived through these changes felt the ground of their certainty shift gently beneath them. What had seemed like the edge of everything became a doorway into something larger. And each time, after the first surprise, the larger universe came to feel like home, just as the smaller one had. We stand now at the latest of these moments, looking out across a cosmos of trillions of galaxies, expanding and accelerating in every direction. And there is every reason to think that this, too, is not the final picture. The room is still growing. The doorway still opens onto more. So, as we begin to climb tonight, hold the question lightly. We are not searching for a final number, because there does not seem to be one. We are following a direction, outward, and learning to be at peace inside a universe that has never once stopped opening. It is worth naming, gently, why this single question behaves so differently from all the others. Most things we measure have a true and final size, waiting to be found. The universe is not like that. Its size is genuinely growing, in two separate senses, and so the act of measuring it is less like reading a ruler and more like watching a tide come in. And there is a kindness in approaching it this way, as a direction rather than a destination. If we believed the universe had a final edge, we might feel a quiet pressure to reach it, to know it, to finish the map. But there is no edge to reach, and so there is nothing left undone. We are free, simply to follow the opening out as far as it is willing to take us tonight. Keep in mind, as we climb, that nothing we describe is in any hurry. The growing of the universe happens over millions and billions of years. The growing of our knowledge happens over generations. Nothing out there will change in the span of this night, or your lifetime, or 100 lifetimes. The scale is enormous, and the pace is the slowest there is. Notice, too, how gently the older pictures were replaced, never erased. The close dome of stars was not wrong so much as small. It became the inner room of a larger house. The single galaxy was not a mistake. It became one island among many. Each picture was true as far as it could see, and each was quietly enlarged, rather than overturned, by the one that followed. We are simply the latest to stand in the doorway, looking out at a house grown larger again. For now, let the question settle softly in your mind, without any need to resolve it. The number will not hold still, and it does not need to. We have all the time in the world to follow it outward, slowly, into the dark. Part 2. A ruler made of light. Before we can climb outward, we need a way to measure distances too large for any ordinary ruler. The universe is not measured in miles or kilometers once we leave our own small corner. It is measured in the time it takes light to cross it. Light is the fastest thing there is. It travels about 186,000 miles in a single second, fast enough to circle the whole Earth more than 7 times before that second is finished. Nothing we know of moves more quickly through space. And yet, against the scale of the universe, even light is slow. It takes a little over 1 second for light from the moon to reach us. It takes about 8 minutes for light to travel from the surface of the sun to your eyes. The sunlight that warms you is always 8 minutes old. Out at the cold edge of the planets, light takes more than 5 hours to arrive from the most distant of them. A message sent there at the speed of light and answered at once would take most of a day to return. Already, in our own neighborhood, the distances stretch beyond easy imagining. Because light takes time to travel, every glance into the sky is a glance into the past. You never see a distant thing as it is now. You see it as it was when its light left, whether that was minutes ago, or years, or millions of years. To look out into space is, always, to look back into time. This single idea is the quiet key to everything that follows. When we look at very distant galaxies, we are seeing them not as they are, but as they were long ago, when their light first set out across the growing dark toward a world that did not yet exist. From this ruler comes the unit we will use again and again tonight. A light year. It is not a measure of time, though it sounds like one. It is the distance light travels in a full year, moving at that immense speed without rest. That distance comes to roughly 6 trillion miles, or about 9.5 trillion kilometers. Even our own solar system has a way of growing the more carefully we look at it. Long ago, the edge of everything was the most distant planet anyone could see. Then a wide belt of icy worlds was found beyond it. Then the boundary where the sun's wind fades into the space between stars. And then, surrounding all of it, an immense spherical cloud of comets that may reach a full light year out from the sun, or more. There is a way to picture the scale that helps. Imagine shrinking the sun to the size of a large grapefruit. On that scale, the Earth becomes a single peppercorn, rolling along about 50 feet away. The giant outer planets sit hundreds of feet beyond that. And the nearest other star, the next grapefruit, would lie thousands of miles away, across an ocean of empty room. It helps to dwell on just how immense the gap is between light and everything else we know. A jet airliner crosses an ocean in hours. Light could cross that same ocean dozens of times in a single beat of your center. And yet, set against the universe, even light moves like a patient walker on an endless road. When you look at the sun, you are seeing it not as it is, but as it was 8 minutes ago. If the sun were somehow to vanish, you would feel and see nothing for those 8 full minutes, while its last light continued on its way toward you, faithful and unaware. The sky always shows us the past, never quite the present. This delay grows with distance, and it is the gift that lets astronomy exist at all. Because the light of far things is old, looking outward is the same as looking backward in time. The deeper we see into space, the deeper we see into history, until at the very edge we see the universe as it was near its beginning. The light year, our ruler for the night, is built from this patience. It is the distance light covers in a year of unbroken travel, never slowing, never resting. That single year of light reaches roughly 6 trillion miles into the dark. To cross to the nearest star takes more than 4 such years, even at that unmatched speed. Within our own solar system, the growing of the known has its own quiet history. Each time someone looked more carefully at the outer dark, they found the edge was farther than believed. A faint belt of icy worlds beyond the planets. a boundary where the sun's wind finally gives out, and a great shell of dormant comets, reaching perhaps a full light-year outward. That outermost shell of comets is so distant that the sun, seen from there, would be only a bright star among many, no longer a disk, no longer warm. And still, that shell is bound to the sun, still part of our solar system, still our own backyard. The scale of even the familiar quietly defeats the imagination. And so we set out from here, with our ruler of light in hand, knowing already that the journey ahead is long. The solar system alone would take our fastest craft many thousands of years to leave behind entirely. Beyond it, the distances only deepen, and the ruler of light becomes more precious with every rung. There is a particular comfort in measuring the universe by time rather than by distance. A mile is an abstract thing, hard to feel across the gulfs of space. But the idea that sunlight is 8 minutes old, that the light of the next star is years old, that the light of distant galaxies is older than the world itself, gives the scale a shape the mind can almost hold. Light, for all its speed, is also a kind of memory. It carries the appearance of things forward through time, unchanged, across distances that would take matter an eternity to cross. The image of a far galaxy travels intact for billions of years and arrives still legible, a faithful record of how things once were, delivered to whoever waits to receive it. So as we set out along the ladder, think of each rung not only as a distance, but as a reach into the past. The farther we climb, the older the light, the earlier the moment we are seeing. By the time we reach the most distant galaxies, we will be looking back almost to the beginning, reading the universe's youth in light that has traveled nearly the whole age of the cosmos to find us. And the patience of light has a strange generosity to it. Because it carries the past forward so faithfully, nothing we have ever seen in the sky is truly lost. The light continues outward forever, a record of how things once were, traveling on long after the things themselves have changed. Somewhere, the light of every moment is still in flight, still carrying its small piece of the universe's history into the dark. Our fastest spacecraft, launched decades ago and still moving outward, has only traveled about 1 light day from the sun. At that speed, to cross the gap to the nearest star would take tens of thousands of years. The first lesson of the ladder is a gentle one. Even the part of space we call our own is far too large to cross in a lifetime, and it has only grown larger the more closely we have mapped it. Part 3. The distance to the stars. When we step beyond the solar system, we step into a field of stars, and the distances change their character entirely. They stop being measured in hours of light and start being measured in years of it. The nearest star to our sun lies a little more than 4 light-years away. That means the light you see from it tonight left more than 4 years ago and has been traveling ever since, across a gulf so wide that our fastest probe would need tens of thousands of years to cross it. Measuring such a distance was once thought impossible. How do you find the distance to a point of light with no apparent size, hanging in the dark? The first answer came from a small and patient trick of geometry, one the human eye performs every day without noticing. Hold up a finger at arm's length and look at it with one eye, then the other. The finger seems to jump against the background. That apparent shift, caused by looking from 2 slightly different positions, is called parallax, and it can be turned into a measure of distance. The Earth gives astronomers 2 viewing positions far apart. As our planet swings from one side of its orbit around the Sun to the other, the nearest stars appear to shift, ever so slightly, against the more distant ones behind them. The smaller that shift, the farther away the star. The shifts are almost unimaginably tiny, far too small for the eye alone. But as instruments grew finer, they could measure smaller and smaller shifts, and so could reach greater and greater distances. The stars did not move farther away. Our reach simply grew, and the measurable sky deepened with it. This is the first quiet appearance of the night's central theme, out among the nearest stars. The better we became at measuring, the larger the known universe became. Distances that had been beyond reach fell, one by one, into the grasp of careful astronomers, and the human map of the heavens expanded outward. What that map revealed was a sky far emptier than it appears. The stars look crowded together when you glance up on a dark night, a dense scattering of light. But the spacing between them is enormous. They are typically several light-years apart, with almost nothing in between. Return for a moment to the grain of sand. If the sun were a single grain resting in your palm, the next nearest grain, the next star, would lie several miles away, with empty room in every direction between them. The brightness of the night sky is a beautiful illusion. The truth of it is mostly distance and mostly dark. A second ruler also emerged here, one that would carry us much farther than parallax ever could. A star's true brightness, compared with how faint it appears from Earth, reveals how far away it must be. A candle that looks dim is either weak or far. If you know how bright the candle truly is, its faintness tells you the distance. The first astronomers to measure a star's distance must have felt they were reaching beyond what was permitted. For all of history before them, the stars had been simply there, points of light at an unknowable remove, as far as the idea of distance could stretch. To put a number on that remove was to make the infinite, finite, and astonishing. The shift they measured was almost nothing at all. Even for the nearest stars, the apparent jump caused by the Earth's motion is smaller than the width of a coin seen from miles away. To detect it required instruments of great care and patience, watching the same star across the long swing of a year. And as those instruments improved, the reachable distance grew. A finer measurement could detect a smaller shift, and a smaller shift meant a more distant star brought within reach. The boundary of the measurable sky moved outward steadily, not because the stars changed, but because our patience and precision deepened. What this revealed, more than any single distance, was the emptiness between the stars. We are used to seeing them gathered thickly across the night, a dense and glittering crowd. But that crowding is a trick of perspective. Spread through 3 dimensions, the stars are lonely, separated by years upon years of empty space. If you could travel from the sun toward its nearest neighbor at the speed of our fastest spacecraft, you would spend tens of thousands of years in near total darkness before arriving. The sun would shrink behind you to a single point, and for almost the entire journey, no star would seem any closer than before. The night between stars is great and patient. The second ruler, the comparison of true brightness to apparent brightness, would prove even more powerful than the first. For if there are certain objects whose true brightness we already know, then their faintness alone tells us their distance, no matter how far away they lie. A known candle, however dim it appears, becomes a measuring rod across the dark. This idea would soon carry astronomers past the stars entirely, out beyond the edge of the Milky Way itself. The humble act of comparing how bright a thing is with how bright it looks would unlock the true scale of the universe and reveal that our galaxy, for all its grandeur, was only one island among an ocean of others. The loneliness of the stars is difficult to overstate and worth sitting with for a moment. Between the sun and its nearest neighbor lies more than 4 light-years of almost perfect emptiness, a span so wide that everything within the solar system, every planet and moon and comet would vanish to nothing against it. The stars are not a crowd. They are scattered hermits in an enormous dark. And yet there is a strange peace in that spacing, rather than a sorrow. Each star keeps its long, quiet distance, undisturbed, turning at its own pace, holding its own worlds. The emptiness between them is not a void to be feared, but a kind of room enough that the stars almost never collide, even when whole galaxies pass through one another over the ages. The methods that measured these distances grew steadily more powerful, and with them grew the catalogue of mapped stars. First the nearest few, then hundreds, then many thousands, their distances pinned down by the slow swing of the Earth and the faithful arithmetic of brightness. Each refinement carried the measurable boundary farther into the dark, and the human map of the stars widened to match. There is also a quiet lesson in how the stars were measured at all, which is that the universe yields its scale only to patience. No single glance reveals a star's distance. It takes watching the same point of light across a full year, catching a shift smaller than a hair held at arm's length, and trusting the slow arithmetic. The cosmos does not hide its size so much as ask us to be patient enough to read it. This simple comparison between how bright a thing really is and how bright it looks became the foundation of measuring the universe. It is the first rung of what astronomers call the cosmic distance ladder. And in time, it would let us measure not just the stars, but the galaxies, and reveal a cosmos far larger than anyone had dared to imagine. Part 4. The size of our own galaxy. The next rung upward is the galaxy we live in, the great wheel of stars we call the Milky Way. For most of human history, it was simply the soft band of light across the night sky, and no one knew what it truly was, or how immense. We now know the Milky Way to be a barred spiral galaxy, a flattened disk of stars wound into long curving arms. At its center is a dense bulge, crossed by a bar of stars, and around the whole disk floats a faint sphere of older stars called the halo. From far away, it would look like a slowly turning pinwheel of light. The scale of it is difficult to hold in the mind. The disk of the Milky Way spans roughly 100,000 light-years from edge to edge. Light itself, the fastest thing there is, needs 100,000 years simply to cross from one side of our galaxy to the other. And within that disk are not millions of stars, but hundreds of billions. The count is somewhere between 100 billion and 400 billion, more stars than there are seconds in many thousands of years. Each one is a sun, and many carry worlds of their own, turning quietly in the dark. For a long time, it was natural to assume that we sat near the center of all this, that the sun held some special place in the center of the galaxy. The truth, when it came, was humbling in the gentlest way. We are not at the center at all. The sun lies far out in a quiet stretch of one spiral arm, roughly 26,000 light-years from the galactic core. We live in a calm suburb of the Milky Way, not its bright, crowded center. Our place is ordinary, off to one side, and there is a kind of peace in that ordinariness. The way this was discovered is itself a small lesson in the growing of the known. Astronomers mapped the positions of dense, ancient clusters of stars that orbit the galaxy. Those clusters were not centered on us. They were centered on a distant point, far across the disk, around which the whole galaxy turns. In that moment, the galaxy grew, and our place within it shrank. The Milky Way turned out to be larger than imagined, and we turned out to be living near its edge rather than its middle. The map expanded outward once again, as it always seems to. There is more to our galaxy, too, than the part that shines. Surrounding the visible disk is a far larger sphere of dark matter, a kind of mass we cannot see but can feel through its gravity. The true reach of the Milky Way, measured by its pull rather than its light, is larger than the glowing wheel we can picture. To stand inside the Milky Way and try to measure it is a peculiar challenge. We cannot step outside our galaxy and look back at it. We are within the disk, looking out through it, like someone trying to map a forest while standing among its trees. The soft band of light across the night sky is that disk, seen edge-on from within. And yet, patiently, from inside, astronomers pieced together its true shape and scale. They traced the spiral arms by the bright young stars and glowing clouds that line them. They measured the central bulge, dense with older stars, and the bar of stars that crosses the middle. Slowly, the pinwheel revealed itself, one careful observation at a time. 100,000 light-years across. The number is easy to say and impossible to feel. If the entire Milky Way was shrunk until the distance between the Sun and the nearest star was the width of a single coin, the galaxy would still be wider than a continent. We live within a structure of almost incomprehensible extent, and our place within it is gently humbling. We are not at the center, where the stars crowd close and the great black hole turns at the core. We are far out, roughly 26,000 light-years from the middle, in a calm and unremarkable stretch of one spiral arm. The view from here is quiet, the neighboring stars sparse and far apart. The discovery of our off-center place came from looking at the great globular clusters, dense balls of hundreds of thousands of ancient stars that orbit the galaxy. They were not spread evenly around us. They gathered toward one distant region of the sky, the true center of the galaxy, around which they and we alike slowly turn. It takes the Sun more than 200 million years to complete a single orbit around the galactic center, carrying the Earth and all of us along with it. Since the Sun first formed, it has made this great circuit only about 20 times. The galaxy turns so slowly that an entire human history is less than a flicker within one of its years. Beyond the visible disk lies something larger and unseen. An immense halo of dark matter envelops the galaxy, mass we cannot see but can feel through its gravity, holding the spinning disk together and reaching far past the glowing stars. The true extent of the Milky Way, measured by its pull, is larger than the wheel of light we can picture. Living inside the galaxy we are trying to measure gives our knowledge of it a peculiar, hard-won quality. We have never seen the Milky Way from outside, and we never will. Every picture of it, as a graceful spiral, seen from above, is an informed reconstruction, pieced together from measurements made within the disk, looking outward through the very thing we are mapping. And still, the picture we have assembled is remarkably detailed. We know the winding of the spiral arms, the bar of stars across the center, the great black hole turning at the core, the slow rotation that carries the Sun once around in more than 200 million years. We have charted our home from the inside, patiently, the way one might map a house in the dark by walking its rooms. The slow turning of the galaxy is itself a quiet wonder. In all the time since the Sun first formed, it has carried the Earth only about 20 times around the galactic center. The entire span of human history, every empire and every life, has unfolded within a tiny fraction of a single one of these galactic years. The wheel of the Milky Way turns with a patience that makes our whole story a brief, bright moment. It helps to remember that we are not observers of the galaxy so much as residents within it, carried along on its slow turning. Every star you see by night is a neighbor in the same spiral arm or the ones beside it. All of us drifting together around a center we cannot see, on a journey that takes longer than the age of any mountain. We are passengers on the Milky Way, and the band of light across the sky is the view from inside our own moving home. So even the galaxy we live inside has kept growing in our understanding. Its size was revised outward, its star count climbed, its true extent stretched beyond the visible into the unseen. And all of this was still, in the larger story, only a single island with an ocean of distance waiting beyond its shores. Part 5. The night the universe grew. Of all the moments in the long story of measuring the cosmos, one stands above the rest. It is the moment the universe grew larger than it had ever grown before, not by a little, but by a factor of millions, in a single stroke of understanding. Scattered across the night sky, among the stars, astronomers had long noticed faint smudges of light. Soft spiral shapes, dim ovals, little clouds that did not look quite like stars. For a long time, these were thought to be clouds of gas inside our own galaxy, minor features of a universe that was the Milky Way and nothing more. But a quiet question hung over them, and it was one of the great unresolved puzzles of its age. Were these smudges truly small clouds nearby, inside our galaxy? Or were they something else entirely, something far away? Was the Milky Way the whole of the universe, or only one island among many? The answer, when it came from those special stars whose true brightness can be read from the rhythm of their pulsing. Certain stars brighten and dim in a steady beat, and the pace of that beat reveals exactly how luminous they really are. Find such a star, and you have a candle of known brightness. When one of these pulsing stars was found inside one of the faint spiral smudges, the arithmetic was simple, and the result was staggering. The star's faintness, set against its true brightness, placed it at a distance far beyond the edge of the Milky Way. The smudge was not inside our galaxy at all. It was a galaxy of its own. A separate island of hundreds of billions of stars seen across an immense gulf of space. And if one of the smudges was a distant galaxy, then so were the others, every faint spiral and dim oval scattered across the sky. In that single reclassification, the universe became immeasurably larger. Where there had been one galaxy, ours, there were now galaxies beyond counting, each one a wheel of stars like our own, separated by distances that dwarfed everything that had come before. The cosmos had not changed. We had simply understood what we were already looking at. This is the purest form of the night's theme. The universe grew enormously, not because anything moved or expanded, but because a blur resolved into its true nature. The faint became meaningful. One galaxy became a sky full of them. The known cosmos leapt outward by more than any single step before or since. And the counting did not stop there. Once it was understood that the smudges were galaxies, astronomers began to count them, and the number kept climbing. First, thousands, then millions, then hundreds of billions. The deepest surveys of the sky now suggest the part of the universe we can see may hold on the order of 2 trillion galaxies. It is worth pausing to feel how complete the older picture had seemed. The Milky Way, with its hundreds of billions of stars, was understood to be the whole of the universe. A single great island of light, surrounded by an endless, empty dark, with nothing beyond. For a thinking person of that time, that was creation, entire. The faint spiral smudges were a puzzle within that picture, but a small one. They were assumed to be clouds of glowing gas, scattered among the stars of our own galaxy, minor and local features. No one could be certain, because no one could measure their distance. They were too faint, too featureless, too far beyond the reach of the old methods. The debate over their nature was one of the great open questions of its age. On one side, those who believed the smudges were nearby clouds, and the Milky Way was everything. On the other, Those who suspected the smudges were island universes of their own, distant galaxies, far outside our own. Everything depended on distance, and distance could not yet be measured. Then came the pulsing stars. Certain stars swell and shrink in a steady rhythm, brightening and dimming over days or weeks, and the pace of that rhythm reveals exactly how luminous the star truly is. Such a star is a candle of known brightness, and its faintness in the sky tells its distance with confidence. When such a star was found within one of the spiral smudges, and its distance worked out, the answer ended the debate completely. The star and the smudge that held it lay far beyond the farthest edge of the Milky Way. The smudge was not a cloud within our galaxy. It was a separate galaxy, immensely far away. In that single result, the universe became larger by a factor beyond easy reckoning. Every faint spiral across the sky was now its own island of hundreds of billions of stars, separated from us and from each other by gulfs of distance that made the Milky Way itself seem small. The cosmos had gone from one galaxy to uncountable galaxies in an instant of understanding. And the counting that followed has never truly stopped. Each deeper survey of the sky found more galaxies, fainter and farther, filling every patch of darkness that was looked at closely enough. A small, seemingly empty square of sky, stared at long enough by a patient telescope, fills with thousands of distant galaxies, each one a wheel of worlds. The best estimates now place the number of galaxies within the observable universe on the order of 2 trillion. It is a number assembled not by counting each one, which no one could ever do, but by measuring how thickly they fill the deepest images and reckoning the whole from the sample. The sky, looked at closely enough, is almost entirely galaxies. It is hard, now, to recover how total the older picture was, and so how great the change must have felt. To believe the Milky Way was the entire universe was not a small or foolish idea. It was the careful conclusion of thoughtful people, drawn from everything they could see. The smudges gave no obvious reason to think otherwise until the pulsing stars spoke. And when they spoke, they did not merely add a few galaxies to the count. They multiplied the known universe by a factor the mind can scarcely follow, turning a single island into a sky filled with islands, each as grand as our own. It is perhaps the largest single leap the human picture of the cosmos has ever made, and it came not from a journey, but from understanding a faint light correctly. Ever since, the count of galaxies has done nothing but climb as our instruments reached fainter and farther. Each patch of sky, once thought empty, stared at long enough, fills with galaxies too faint for earlier eyes. The number rose from thousands to millions to hundreds of billions, and the latest reckonings place it on the order of 2 trillion within the part of the universe we can see. It is worth letting the number rest in the mind without trying to grasp it whole. 2 trillion galaxies. If you tried to visit one every second, naming it as you passed, you would not finish in the entire age of the universe so far. And each one is itself a wheel of hundreds of billions of stars. The count is not meant to be held. It is meant only to be felt softly, the way one feels the size of an ocean while standing at its edge. And like the ocean, it does not ask to be counted, only to be witnessed for a little while by someone willing to stand quietly before it. 2 trillion galaxies, each with its hundreds of billions of stars. The mind cannot truly hold a number like that, and it does not need to. It is enough to let it rest there softly, a sky so full of islands of light that no one will ever count them all, stretching away into a distance we have only begun to measure. Part 6. The nearest great galaxy. Having learned that the smudges are galaxies, let us drift toward the nearest large one, and let the pace slow as we go. After the leap of the last part, this is a place to rest the eyes for a while. The nearest great galaxy to our own is called Andromeda. It lies about 2.5 million light-years away, and on a clear dark night, far from any city, you can just make it out with the unaided eye. A faint oval of soft light, no brighter than a smudge of cloud. That faint patch is the most distant thing the human eye can see without any instrument at all. Everything else you can see by eye lies within our own galaxy. Andromeda alone is far beyond it, a separate island of stars, seen across 2.5 million light-years of empty space. Think for a moment about the light that carries that image to you. It left Andromeda about 2.5 million years ago, long before our species existed in its present form, and has been traveling ever since, crossing the growing dark to arrive at your eye on this particular night. To look at it is to look across an unthinkable reach of both space and time. Andromeda is, like our Milky Way, a great spiral wheel of stars, and the two of them are the giants of a small family of galaxies bound together by gravity. We call this family the local group. It holds several dozen galaxies in all, most of them small, spread across roughly 10 million light-years of space. There is something quietly important about this little family, and it will matter a great deal later tonight. The local group is held together by its own gravity. Because of that, it does not take part in the great expansion of the universe. While the space beyond it stretches and grows, the local group holds together, an island that stays whole. Andromeda is also slowly drifting toward us, drawn by that same gravity. Over a span of billions of years, far longer than any human horizon, our two galaxies will gently approach and begin to merge. It will not be a collision in the way we might fear. The stars within galaxies are so far apart that almost none of them will ever touch. Instead, it will be a slow, flowing together, a merging of two great wheels of light over hundreds of millions of years, until at last they settle into a single larger galaxy. By then, this night will be so long past that nothing of it will remain. There is a strange comfort in that depth of time, in knowing how unhurried the universe truly is. There is something tender about Andromeda being just barely visible to the unaided eye. It sits at the very limit of human sight, a soft grey oval that you can only catch on a truly dark night, often more easily from the corner of the eye than head-on. It is the farthest the eye alone can ever reach, and it reaches 2.5 million light-years. What you see, when you find it, is not the whole galaxy. The faint patch visible to the eye is only the bright central core. The full disk of Andromeda, if our eyes were sensitive enough to catch all of it, would stretch across the sky several times wider than the full moon. We see only the lit center of something far larger. Andromeda is, in fact, a great spiral much like our own, holding 1 trillion stars or more, with its own spiral arms, its own central bulge, its own quiet swarms of orbiting clusters. It is a true sibling to the Milky Way, the other giant in our small corner of the cosmos, turning slowly through the same long dark. The light that brings it to you tonight is older than our species in its present form. It set out when our ancestors were still finding their way in a young world, and it has crossed 2.5 million light-years of growing space to arrive, unbroken, at this moment, in your eye. To look at Andromeda is to receive a message sent across an unthinkable depth of time. Around these two giants gathers the local group, our gravitationally bound family of galaxies. Most of its members are small, faint dwarf galaxies, dozens of them, drifting in slow orbits around the two great spirals. Together they span roughly 10 million light-years, a quiet household in the larger structure of the cosmos. The most important thing about this family, for our story, is that it holds together. Its own gravity binds it firmly enough that the expansion of the universe cannot pull it apart. While the wider cosmos stretches and grows, the local group remains a single, stable island. It does not grow. It will not scatter. It stays whole. That stability becomes a kind of refuge in the far future story we will reach later. For now, simply hold the image of this small bound family drifting together through the growing dark, two great wheels of light and their quiet attendant dwarfs, keeping each other company across the ages. It is, in a sense, the largest thing we will ever truly belong to. Andromeda rewards a patient eye in a way few sights do. On a clear, moonless night, far from city light, you can find it as a soft smudge near a familiar pattern of stars, and know, as you look, that the light entering your eye has crossed 2.5 million years of space to reach you. No other thing visible to the unaided eye is anywhere near so far or so old. There is a quiet intimacy in the fact that we and Andromeda are siblings, two great spirals among a scattering of smaller companions. We are not alone in our kind. Across that immense gulf turns another wheel of 1 trillion stars, with its own arms and its own worlds, drifting through the same slow dark, bound to us by the gentlest of gravitational ties. And the two of us are very slowly drawing together. Over a span of billions of years, far beyond any horizon a person need consider, Andromeda and the Milky Way will approach and gradually merge into a single greater galaxy. It is not an event to dread, but a meeting unimaginably slow, unfolding over more time than has passed since the first life appeared on Earth. And there is a quiet thought to carry from Andromeda before we climb on. Somewhere within that faint oval of light are 1 trillion suns, and around many of them, worlds we will never know, turning through their own nights. The light that left them set out before our story began, and it arrives tonight, unhurried, asking nothing, simply offering the view across 2.5 million years of space for anyone willing to look. For now, Andromeda hangs there in the autumn sky, a soft oval of ancient light, the near shore of the universe beyond our own galaxy. It is the first stepping stone outward, into a realm where the islands of stars are themselves only grains, gathered into structures larger still. Part 7. The Web of Worlds. From the local group, we climb again, and the scale shifts beneath us once more. The galaxies, it turns out, are not scattered evenly through space like grains thrown at random. They gather. They cluster. They arrange themselves into something with a shape. Galaxies collect first into small groups, like our own local group. Groups gather into clusters, great swarms of hundreds or thousands of galaxies bound together. And clusters gather, in turn, into superclusters, larger still. At every level, the structure grows, one scale nested inside the next. The nearest large cluster of galaxies to us lies roughly 50 to 65 million light-years away, and contains well over 1,000 galaxies, all held together by their mutual gravity. From within our quiet group, we feel the distant pull of that great crowd of light. Our own supercluster is larger still, a sprawling network spanning some 500 million light-years and containing on the order of 100,000 galaxies. All of them, including ours, drift slowly along unseen streams of gravity, flowing together toward a common region, like leaves carried on the surface of a wide, slow river. And on the very largest scales, the galaxies trace out a pattern of remarkable beauty. They string themselves into long, luminous filaments, threads of galaxies running for hundreds of millions of light-years, meeting at dense, bright knots where clusters gather. Between the threads lie immense, nearly empty spaces, the great voids. Astronomers call this pattern the cosmic web. Seen on a large enough scale, the whole universe resembles a foam or a tangle of bright filaments strung through a dark room, with immense hollow bubbles of emptiness between them. The galaxies are the glints of light along the threads. The spaces between are mostly nothing at all. Here too, the known universe kept growing as we learned to map it. Each new survey of the sky tended to reveal larger structures than the one before. Longer filaments, wider walls of galaxies, deeper voids. The scale of cosmic architecture was pushed outward again and again as our reach extended across the sky. And most of what shapes this web cannot be seen at all. Everything that shines, every star and galaxy and glowing cloud of gas, makes up only about 5% of the universe. Roughly a quarter is dark matter, felt only through its gravity, forming the unseen scaffolding along which the bright galaxies gather. The remaining 2/3 is something stranger still, called dark energy. It is not matter at all, but a property of empty space itself, and it is the force quietly driving the universe to expand. We will return to it soon, for it is the deepest reason the universe never stops growing. The gathering of galaxies into larger and larger structures is one of the loveliest patterns in nature. It is the same impulse we see in so many things, the tendency of matter to draw together under gravity, repeated at a scale almost beyond comprehension. Galaxies into groups, groups into clusters, clusters into superclusters, each level a quiet reflection of the one below. A cluster of galaxies is a remarkable thing to picture. Hundreds, sometimes thousands of galaxies, each a wheel of hundreds of billions of stars, all bound together by gravity and moving slowly through one another over billions of years. Between them drifts a thin, hot gas, and around them all stretches an unseen web of dark matter, holding the whole assembly together. Our own supercluster is a structure so large that we have only recently traced its true shape. It spans some 500 million light-years, and within it, all the galaxies, including ours, are flowing gently along streams of gravity toward a common region. We are being carried, slowly and steadily, as part of a current far larger than our galaxy or our group. Step back far enough, and the superclusters themselves arrange into the grandest pattern of all. The galaxies trace long, bright filaments, threads strung across hundreds of millions of light-years, meeting at dense knots where the great clusters gather. And between the threads lie the voids, immense bubbles of near emptiness, each one larger than the structures that surround it. This is the cosmic web, and the name is well chosen. On a large enough scale, the universe genuinely resembles a web or a sponge, or the foam on a cresting wave, with bright matter gathered along the strands and walls and immense hollow spaces in between. Most of the volume of the universe is void. The galaxies cling to the edges of the emptiness. And here, once more, the known kept growing as we learned to see. Each deeper survey of galaxy positions revealed larger structures than the last. Longer filaments, broader walls of galaxies, voids so wide that light takes hundreds of millions of years to cross them. The architecture of the cosmos was pushed outward again and again as our maps reached farther. Beneath all of this visible structure lies the unseen majority. Everything that shines, every star and galaxy and glowing cloud, is only about 5% of what the universe contains. About a quarter is dark matter, the invisible scaffolding whose gravity gathers the galaxies along the strands of the web. The bright cosmos is a thin frost on a far larger and darker frame. And the remaining 2/3 is dark energy, woven into the emptiness itself, quietly pushing the whole structure wider. It is the reason the voids grow, the reason the filaments slowly stretch, the reason the universe never settles. We will turn to it fully soon, for it is the deepest answer to why the cosmos never stops growing. The way galaxies gather into ever larger families is, in a sense, the universe building structure out of its own gravity, patiently, over billions of years. From the smooth and nearly featureless beginning, the faint, early unevenness has been drawn together, strand by strand, into the great web we see today. Gravity is a slow architect, but it has had all the time in the world. To picture our place in this architecture, imagine being carried on a current you cannot feel. Our galaxy, our whole local group, drifts along streams of gravity toward a distant region, pulled by the gathered mass of structures larger than we can easily map. We are not still. We are flowing, slowly and steadily, as one small part of a far greater motion through the web. The emptiness of the voids deserves its own quiet wonder. These are spaces so large that light takes hundreds of millions of years to cross them, and so empty that a traveler within one might see almost no galaxies at all in any direction. The bright web clings to the edges of these immense hollows, and most of the volume of the universe is exactly such gentle, patient emptiness. Step far enough back, and even the grandest galaxies become mere points of light along the threads of the web, and the web itself becomes the truest portrait of the universe at the largest scale. It is a structure of luminous filaments and immense hollows, grown patiently from the faint unevenness of the beginning. To see it whole is to see the cosmos not as scattered stars, but as a single, slowly unfolding form, woven through with light and shaped by gravity over billions of years. So the bright web of galaxies, for all its grandeur, is only the visible foam atop a far larger and darker sea. The structures we can map are immense beyond imagining, and yet they float within something larger, something unseen, that fills the whole of space and gently pushes it ever wider. Part 8. When space itself began to stretch. Until now, we have climbed through the universe as if it were a fixed and finished thing, a great structure waiting to be measured. But the deepest discovery about the cosmos is that it is not fixed at all. It is moving. It is growing. And this is the second kind of growing the night has been carrying. The clue came from the light of distant galaxies. When that light is spread out into its colors, the way sunlight spreads into a rainbow, the pattern within it is shifted toward the red end. And this shift toward red is a sign of motion. The galaxies are receding from us, drawing away. Stranger still, the farther away a galaxy is, the faster it appears to be receding. The most distant galaxies draw away the quickest, and the nearer ones more slowly, in a smooth and steady relationship that holds across the whole sky. This was the first hint that something remarkable was happening to space. The natural reading was not that the galaxies are flying outward through space from some central point, like debris from an explosion. It is that space itself is stretching everywhere at once, carrying the galaxies apart as it grows. The galaxies are not racing through space. The space between them is lengthening. There is a gentle way to picture this. Imagine raisins set into a loaf of bread dough as it slowly rises. As the dough expands, every raisin moves away from every other raisin. No raisin is at the center. From the point of view of any one of them, all the others are drawing away, and the farther ones recede the fastest. Or imagine dots drawn on the surface of a balloon as it is slowly inflated. Every dot moves away from every other dot. There is no center to the motion on the surface, and no edge that the dots are moving toward. Each dot, if it could see, would believe itself to be the still point around which all the others retreat. This is exactly what we find in the universe. From any galaxy, in any direction, all the others appear to recede. There is no center to the expansion that we could ever point to, and no edge it is growing into that we could ever reach. Space is simply everywhere, getting larger. One detail matters greatly, and it brings a quiet reassurance. The expansion only stretches the open, unbound gaps between distant galaxies. It does not pull apart anything held together by its own gravity or by the forces within it. Atoms do not grow. Planets do not drift apart. The Sun, the solar system, our galaxy, and the whole local group all hold together. Only the wide, empty seas between the gravitational islands are growing. The islands themselves stay whole. This is why the universe can grow even when nothing, in the ordinary sense, is moving. The galaxies rest nearly still in their own neighborhoods, while the distances between neighborhoods quietly, endlessly lengthen. The discovery that the universe is expanding ranks among the most profound in all of human thought. For all of history before it, the cosmos had been imagined as fixed and eternal, a stage on which the stars played out their slow motions, unchanging in its overall size. The finding that space itself is growing overturned that picture entirely. The evidence was written in the colors of distant light. When the light of a galaxy is spread into its spectrum, certain features within it sit at particular places, like markers. In the light of distant galaxies, those markers are shifted toward the red, and the shift is greater for galaxies that are farther away. The pattern is smooth, and it covers the whole sky. The simplest reading of that pattern is not that galaxies are flying outward through space from a center. It is that space itself is expanding, swelling uniformly everywhere, carrying the galaxies apart as it grows. They are not moving through space so much as being carried by it, like leaves resting on the surface of a slowly widening pond. The raisin bread is the gentlest image for this. As the dough rises, every raisin drifts away from every other raisin, not because the raisins are moving through the dough, but because the dough between them is expanding. There is no central raisin. From the view of any one, all the others recede, and the most distant recede the fastest. The balloon gives the same lesson in a different form. Mark dots on its surface, then inflate it, and watch every dot move away from every other. No dot is the center of the motion, because the center is not on the surface at all. And there is no edge on the surface that the dots approach. The surface simply grows everywhere, all at once. Apply this to the real universe, and a great truth follows. There is no center to the expansion that we could ever find, and no edge it is expanding into that we could ever reach. From every galaxy, the view is the same. All the others recede in every direction, and each observer feels wrongly like the still point at the center of it all. The reassurance hidden in all this is easy to miss, so let us state it plainly. The expansion does not pull apart the things that are bound. Your body, the Earth, the Sun, the solar system, the whole Milky Way, the entire local group, all of these are held together by gravity, and the forces within them far too strongly for the gentle stretch of space to undo. Only the wide, unbound gaps between distant galaxies grow. So the universe can grow without anything truly moving. The galaxies rest, more or less, in their own neighborhoods, while the distances between neighborhoods lengthen, second by second, with a patience beyond all hurry. And if we run that growing backward in the mind, everything draws together toward a hot, dense beginning, some 14 billion years ago, from which the whole opening out began. Sit for a moment with how completely the idea of an expanding universe overturned the old certainty of a fixed cosmos. For all of history, the heavens had been the very image of permanence, the one thing that did not change. To learn that space itself is growing, everywhere, all the time, was to learn that even the stage on which everything happens is quietly in motion. And the motion is wonderfully democratic. There is no privileged galaxy at the center of the expansion, no special place from which everything flees. From every point in the universe, the view is the same, all the other galaxies drawing gently away, the farther ones faster. Everyone, everywhere, sees themselves at the still center of a universe that is opening out around them. Hold on to the reassurance woven through all of this. The expansion stretches only the open spaces between unbound galaxies. It does not reach inside the things that gravity and the other forces hold together. You are not being stretched. The Earth is not growing. The solar system and the galaxy and the whole local group hold firm, islands of stillness in a slowly widening sea. And once you accept that space itself can stretch, a great deal that seemed strange falls quietly into place. The reddened light of distant galaxies, their orderly retreat, the absence of any center, the way the universe can grow without anything truly moving through it. All of it follows from the single, gentle idea that the space between unbound things is lengthening, everywhere, all the time, with a patience that has held since the beginning. And there is one more thing this growing tells us. If space is expanding now, then in the past it was smaller. Run the growing backward, in the mind, and everything draws together, closer and closer, hotter and denser, toward a single beginning around 14 billion years ago. From that beginning, all of this opening out began, and it has not stopped since. Part 9. Larger than its own age. Now we come to one of the most beautiful and confounding facts in all of astronomy. It is the kind of fact that seems wrong when you first meet it, and then becomes more wonderful the longer you sit with it. The universe is larger than its own age would seem to allow. Here is the natural guess. If the universe is about 14 billion years old, then surely the farthest we could possibly see is about 14 billion light-years away. Light could only have traveled for 14 billion years, so it could only have crossed 14 billion light-years of space. It sounds airtight. And it is wrong. The reason it is wrong is the very thing we learned in the last part. Space has been stretching the entire time. While the light from a distant galaxy was crossing the universe to reach us, the space it was traveling through kept growing beneath it. The light moved forward, but the ground it covered lengthened as it went. Picture a traveler walking along a road, while the road itself is slowly being stretched. The traveler keeps walking at a steady pace, but the distance behind grows longer than the steps alone would explain, because the road kept expanding during the journey. The light from distant galaxies is exactly that traveler. So the galaxies whose ancient light is only now arriving at our telescopes are no longer where they were when that light first set out. The expansion has carried them much farther away in the time the light spent crossing toward us. The light is old, but its source has been swept onward, deeper into the growing dark. Work the numbers through, and the result is astonishing. Although the oldest light we can see has been traveling for more than 13 billion years, the galaxies that first emitted it are now about 46 billion light-years away. The space simply grew while the light was in transit. This means the observable universe, the sphere of everything whose light has reached us, reaches roughly 46 billion light-years in every direction. From edge to edge, it spans about 93 billion light-years. The universe we can see is far larger than 14 billion light-years, far larger than the simple guess would allow. The number is larger than its own age, and it is larger for a reason that goes to the center of tonight. The ruler itself grew while we were measuring. The universe expanded during the very journey of the light that lets us see it. And so the figure, once again, grows beyond what we first expected. Few facts in astronomy resist intuition as stubbornly as this one. We are so used to the idea that nothing can outrun light, and that the universe has a finite age, that the natural conclusion seems unavoidable. The farthest we could see should be the distance light could travel in the lifetime of the cosmos. And yet the real number is several times larger. The error in the simple guess is that it imagines a static universe, one whose distances stay fixed while light crosses them. But the universe is not static. It has been expanding the entire time, stretching every distance within it, including the very path that the ancient light has been traveling along. Return to the image of the walker on a stretching road. The walker moves at a steady pace, never slowing. But the road behind keeps lengthening as the walk goes on, so that the total distance covered grows larger than the walker's steady steps alone would account for. The journey ends up far longer than the simple reckoning would predict. The oldest light we can detect set out more than 13 billion years ago from young galaxies in the early universe. It has been traveling toward us ever since, at the unchanging speed of light. But the space it has crossed kept expanding beneath it, so the galaxies that emitted it have been carried far onward in the meantime. Those galaxies are no longer 13 billion light-years away. They are now about 46 billion light-years away, swept outward by the expansion during the long ages while their light was in flight. We see them as they were, young and near, but they are now far older and immeasurably more distant, if they survive at all. And so the observable universe, the sphere of everything whose light has reached us, reaches roughly 46 billion light-years in every direction. From one side to the other it spans about 93 billion light-years, far larger than its age of 14 billion years would ever suggest. The figure outgrows its own age, because the ruler grew while we measured. There is a quiet beauty in what this means for our seeing. When we look at the most distant galaxies, we are not seeing where they are. We are seeing where they were, long ago, frozen in the old light. The galaxies themselves have drifted on, far past our horizon, carried by the same gentle growing that fills all of space. It is a little like receiving a letter written in childhood by someone now grown old and moved far away. The letter is real, and the person is real, but they are no longer the child who wrote it, and no longer in the place from which it was sent. The light of distant galaxies is exactly such a letter, arriving across billions of years from a sender long since carried elsewhere. Let this fact arrive slowly, because it rewards patience. The universe is about 14 billion years old, and yet the things we can see in it lie as far as 46 billion light-years away. The seeming contradiction dissolves entirely once you remember that the space between us and those things has been growing the whole time their light was traveling. It means that distance, in an expanding universe, is a subtler thing than it first appears. There is the distance the light has traveled, and there is the distance to where the source sits now. And the two are not the same, because the ground itself lengthened during the journey. The universe is large, in part because it has been busy growing larger throughout its own history, and it places a gentle limit on our seeing that has nothing to do with the strength of our telescopes. Even the perfect instrument could only gather light that has had time to reach us. The observable universe is the sphere of all such light, 93 billion light-years across, and beyond its edge lies more that we simply have not yet received, and in some cases, never will. Let this stand as one of the quiet marvels of the night, then. We can see things that lie far farther away than light could have traveled in the whole age of the universe, because the universe kept growing while that light was on its way. The number is larger than its years, and the reason is woven into the fabric of space itself. The cosmos is large, in part because it has spent its entire life becoming larger. There is something almost gentle about this when you let it settle. We reach out with the oldest light there is, light that left when the first galaxies were young, and it tells us not where those galaxies are, but where they were. The places themselves have drifted on, far beyond our seeing, carried by the same slow growing that fills the whole of space. Part 10. The growing that speeds up. We have seen that space is stretching, and that the stretching makes the universe larger than its age alone would suggest. But there is a deeper layer beneath even this, and it is the truest reason the universe never stops growing. The growing itself is speeding up. For a long time, it was assumed that the expansion must be slowing down. After all, the universe is full of matter, and matter has gravity, and gravity pulls inward. It seemed only sensible that the great opening out begun at the beginning would gradually be reined in, slowed by the combined pull of everything within it. When astronomers finally measured the expansion carefully enough, using distant exploding stars as markers across billions of years, they found the opposite of what they expected. The expansion is not slowing at all. It is accelerating. The universe is growing faster now than it was long ago. Something is pushing space apart, more strongly than gravity is pulling it together, and pushing harder as time goes on. We call this something dark energy, though the name is mostly a label for our uncertainty. It appears to be a property of empty space itself, a faint outward pressure woven into the vacuum. And here is the quiet engine of it. The more space there is, the more dark energy there is, and so the stronger the outward push becomes. As space grows, it creates the conditions for itself to grow faster still. The expansion feeds upon itself, gently compounding, century after century, eon after eon. This has a consequence that sounds impossible at first. The most distant galaxies are receding from us faster than the speed of light. They are drawing away so quickly that their light can never close the gap between us. We will never see them as they are now, and in time, we will not see them at all. This breaks no law of nature, and it is worth pausing to understand why. Nothing is moving through space faster than light. The galaxies sit nearly still in their own regions. It is the space between us and them that is growing, and space itself has no speed limit. It can stretch as fast as it likes, carrying distant things beyond our reach. There is a boundary then, set by this runaway growing, called the cosmic horizon. Beyond it, the recession outruns the light, and whatever lies past it is hidden from us forever, not by distance alone, but by the endless stretching of the space in between. This is the most literal sense in which the universe never stops. It is not merely large. It is not merely growing. It is growing ever faster, the rate of its own enlargement quietly increasing, with no end to the process anywhere in sight. The thumbnail words for tonight are simply true. It never stops. For most of the time astronomers studied the expanding universe, they expected to be measuring how quickly it was slowing down. The logic seemed sound. The universe is full of matter. Matter has gravity, and gravity pulls inward. Surely the great outward growing begun at the beginning was being gradually braked by the combined pull of everything in it. The hope was to measure that braking, and from it, to learn the universe's fate. Would gravity eventually halt the expansion and pull everything back together? Or would the growing slow but never quite stop, coasting outward forever? To find out, astronomers measured the expansion across billions of years, using distant exploding stars as markers of known brightness. What they found was not a braking at all. The expansion was speeding up. In the distant past, it had grown more slowly, and as time went on, it had grown faster, and it is growing faster still today. Something was pushing the universe apart more strongly than all its matter could pull it together, and pushing harder as the eons passed. That's something we call dark energy, though the name conceals how little we understand it. It behaves as though it is a property of empty space itself, a faint and steady outward pressure built into the vacuum. Where there is space, there is this gentle push, and the universe is making more space all the time. Here is the quiet engine that makes the growing endless. The more space exists, the more dark energy there is, and so the stronger the outward push becomes. Expansion creates space, and space creates more expansion, in a slow, compounding loop that has no natural end. The universe is, in effect, teaching itself to grow ever faster. This leads to something that sounds, at first, like a contradiction. The most distant galaxies are receding from us faster than light itself. They are drawing away so quickly that the light they send out can never close the gap to reach us. Between us and them, space is being created faster than light can cross it. And yet no rule of nature is broken, which is worth understanding gently. Nothing is moving through space faster than light. The galaxies sit nearly still in their own regions, just as we do in ours. It is the space in between that grows, and space has no speed limit. It may stretch as quickly as it likes, carrying distant things beyond all reach. This sets a boundary on what we can ever see, called the cosmic horizon. Beyond it, the recession of space outruns the light, and whatever lies past it is hidden from us not by mere distance, but by the endless, accelerating stretching of the space between. It is the most literal sense in which the universe never stops and never will. Yet for all its grandeur, the acceleration is unimaginably gentle on any scale a person could feel. Across an entire human life, the nearby sky barely changes at all. The great speeding up unfolds over billions of years, so slowly that to us it is indistinguishable from perfect stillness. The universe races outward, and the night above you holds completely still. The discovery that the expansion is accelerating reshaped our sense of the universe's future as profoundly as the expansion itself once reshaped its past. We had imagined the great growing might one day halt, or reverse, gravity drawing everything back together. Instead, we learned that the opening out will continue without end and quicken as it goes. Dark energy remains one of the genuine open questions of our age, and there is an honesty in admitting how much it hides from us. We can measure its effect with care. We can watch the expansion speed up across billions of years. But what it truly is, why empty space should carry this faint outward pressure at all, we do not yet know. The name is a marker for a mystery we have not solved. What we can say is that its influence grows with the room it is given. As space expands, there is more space, and so more of this outward pressure, and so the expansion presses onward faster still. It is a slow, self-feeding process, unhurried beyond all telling, and it points toward a universe that grows larger and emptier and quieter across the long ages ahead. And so, the future the acceleration points toward is one of ever greater room and ever greater quiet. The galaxies will draw apart, the spaces between them will widen without end, and the universe will grow slowly, emptier, and calmer across ages beyond counting. It is not an ending so much as a long, gentle dispersal, unfolding so slowly that, to anyone alive within it, the night sky holds perfectly still. And yet the feeling of it, when you rest with it, is not one of alarm. The acceleration is unimaginably gentle on any human scale. Across an entire human lifetime, the nearby sky barely changes at all. The great speeding up belongs to spans of billions of years, far beyond any night, far beyond any worry, turning so slowly that to us it is almost perfect stillness. Part 11. the edge that keeps retreating. Let us return now to the first kind of growing, the growing of our own reach, and bring it all the way up to the present. For while space stretches on its own, the known universe also grows, each time we build a finer instrument and look more deeply into the dark. Every generation of telescope sees fainter, earlier, and more distant galaxies than the one before it. The edge of the known universe is not a fixed wall. It is a frontier that retreats before us, stepping farther back each time our eyes grow sharper. We have never reached it. We have only ever pushed it outward. Our newest instruments are built to catch the faintest light of all, the deeply reddened glow of the very first galaxies. Light so stretched by the expansion that it has slipped out of visible color into the warmth of the infrared. To catch that light is to look back almost to the beginning of all structure. With these new eyes, the record for the most distant known galaxy has been pushed back further than ever before, to galaxies whose light set out within a few 100 million years of the beginning. We are seeing the universe in its infancy, the first wheels of stars assembling out of the early dark. And these deepest looks have held genuine surprises. The early galaxies have turned out to be more numerous, brighter, and more fully formed than expected, appearing sooner than our models predicted they could. The universe keeps turning out to be richer and earlier than we thought, and our picture of it must keep widening to fit what we find. Each such discovery enlarges the known cosmos. Not the universe itself, which neither knows nor cares that we are watching, but the portion of it that we have seen, catalogued, and understood. With every improvement in our instruments, the known universe grows, in count and in reach and in age. There is no sign anywhere that we have come to the bottom of the well. Every deeper look has so far revealed more, not less. More galaxies, more distance, more structure, more time. The frontier keeps moving outward, and the number that answers how much we can see keeps climbing. This is worth holding gently, alongside the physical expansion, for the two kinds of growing meet here. Space stretches, carrying things farther away. And our reach stretches too, gathering more of that growing cosmos into the light of human understanding. Both move in the same direction. Both move outward. Neither, so far, has stopped. There is a second engine driving the number outward, and it sits not in the depths of space, but in our own patient ingenuity. Even if space held perfectly still, the known universe would still grow, each time we built a finer instrument and turned it on the dark. The frontier of the seen retreats before every improvement in our sight. Each new telescope is, in a sense, a deeper well dropped into the past. The fainter the light it can gather, the older and more distant the galaxies it can reach. And every time we have managed to gather fainter light, we have found more universe waiting there, galaxies that were always present, but always, until then, just beyond our seeing. Our newest eyes are tuned to the faintest light of all, the deeply reddened glow of the earliest galaxies. Their light set out so long ago and has been stretched so far by the expansion that it has slipped entirely out of visible color and into the gentle warmth of infrared. To catch it, our instruments must be patient, cold, and exquisitely sensitive. With these new eyes, the record for the most distant known galaxy has been carried further back than ever, to galaxies whose light departed within a few 100 million years of the beginning. We are now seeing the universe in its earliest infancy, watching the very first wheels of stars take shape out of the young dark. And what we have found there has been genuinely surprising. The earliest galaxies appear more numerous, brighter, and more fully formed than the models expected them to be at such an early age. The universe seems to have assembled its first structures faster than we believed it could, and our picture of those first ages has had to widen to fit what we actually see. Every such finding enlarges the known cosmos. Not the universe itself, which proceeds entirely indifferent to our watching, but the portion of it we have gathered into the light of understanding. With every advance, the catalogue of what we can see grows in number, in distance, and in age, reaching ever closer to the beginning. And there is no sign, anywhere, that we have come to the bottom. Every deeper look has revealed more, never less. More galaxies, more distance, more structure, more time. The frontier of the known keeps moving outward, and so far it has shown no inclination to stop. The deeper we look, the more there turns out to be. So the two growings meet, here, in the present age. Space stretches, carrying the galaxies ever farther into the dark. And our reach stretches too, gathering more of that growing cosmos into the light of human knowing. Both move outward, together, in the same patient direction, and neither, in all our history, has yet come to rest. There is something quietly heroic in the patience our instruments require to reach the earliest light. To gather a single faint image of the first galaxies can take many hours of steady staring at one small patch of sky, collecting the rare, ancient photons one by one as they arrive after their journey across nearly the whole age of the universe. The faintest light asks the greatest patience, and the reward for that patience has been a steady widening of the known. Each generation of instruments has carried the frontier of the scene further back, toward fainter, older, more distant galaxies, until we now witness the universe in its first few 100 million years, watching the earliest structures gather out of the young dark. The edge of the known keeps stepping backward as our sight improves. It is worth holding the two growings together one more time, here in the present. The universe expands on its own, indifferent to whether anyone is watching, carrying the galaxies apart across the ages. And our reach expands alongside it, gathering more and more of that growing cosmos into the light of understanding. The frontier moves outward in both senses at once, and neither has shown any sign of stopping. There is a kind of partnership in this, between the patient universe and the patient eye. The cosmos has spent billions of years sending its ancient light toward us, and we have spent generations learning to catch it, fainter and older with each advance. Neither hurries. The light arrives when it arrives, and we gather what we can, and with every gathering the known universe grows a little larger and a little older than it was before. And so the known universe of tonight is larger than the known universe of a generation ago, which was larger than the one before. Each clear night, somewhere, a deeper image is being gathered, and the catalogue of everything we can see grows by another faint and ancient point of light, arriving at last from the edge of time. Part 12. Beyond everything we can see. Now we come to the step that the whole night has been quietly preparing. Everything we have climbed through so far, every galaxy and cluster and filament, the entire 93 billion light-years of it, lies within the observable universe. And the observable universe is not the whole universe. The observable universe is simply the sphere from which light has had time to reach us in the age of the cosmos. It is the part we can see, because its light has arrived. But there is no reason at all to think that the universe stops at the edge of our seeing. That edge is a limit of our vision, not a wall of the cosmos. Consider what we actually find when we look out to the farthest reaches we can observe. In every direction, at the largest scales, the universe looks the same kinds of galaxies, the same cosmic web. The same gentle, even distribution of matter spread smoothly across the sky, with no special place and no sign of any boundary. If the universe looks the same everywhere we can see, in every direction, then the simplest and most natural reading is that it continues, much the same, far beyond what we can see. Our horizon is not where the universe ends. It is only where our light runs out. By the most careful reasoning available, the whole universe is at least hundreds of times larger than the part we can observe, and may well be infinite, with no edge and no center anywhere within it. The 93 billion light-years we can map may be a small, bright bubble within something without any size at all. And there is a humbling symmetry to our place in it. We sit at the exact center of our observable sphere, but only because that sphere is defined by our own light, reaching out equally in all directions. We are at the center of what we can see, and so is everyone, everywhere. An observer in the most distant galaxy we can detect would find themselves at the center of their own sphere, with their own horizon, seeing regions of the universe that we never can, and unable to see some of what we see. There are countless such spheres, overlapping across the cosmos, each one centered on whoever is looking. So the true answer to how big the universe is may have no finite form at all. The part we can measure keeps growing, with every instrument and every passing age. But the part beyond our horizon may have no size that anyone could ever write down. It may simply go on. It is easy, after climbing through 93 billion light-years of galaxies, to feel that we have surely reached the whole of it. But the observable universe is defined by something very particular and very local. It is the sphere from which light has had time to reach us, in the age of the cosmos. It is bounded by the speed of light and the lifetime of the universe, not by any feature of the universe itself. Think carefully about what that boundary really is. It is not a wall. It is not a shore. It is simply the distance beyond which the light has not yet arrived. There may be galaxies just past it, much like the ones we see, whose light is still on its way and has not reached us, and may never reach us. The edge of our seeing is not the edge of what exists. And when we examine the universe at its largest observable scales, everything we find argues for more, beyond. In every direction, the cosmos looks essentially the same. The same kinds of galaxies, the same web of filaments and voids, the same smooth and even distribution of matter. There is no thinning toward an edge, no sign that our region is special or central. If the universe looks the same everywhere we can see, in every direction, the most natural conclusion is that it continues, much the same, far past the limit of our sight. To imagine that the universe happens to stop precisely at the edge of what our particular light can reach would be to imagine ourselves at a strange and unlikely center of everything. By the most careful reasoning we have, the whole universe is at least many hundreds of times larger than the part we can observe, and may well be infinite, without edge or center anywhere within it. The 93 billion light-years we can map may be only a small, bright bubble afloat in something without any size at all. And our central position is an illusion of perspective, shared by everyone. We sit at the exact middle of our observable sphere, but only because that sphere is drawn by our own light, reaching outward equally in all directions. We are at the center of what we can see. So is every observer, on every world, throughout the cosmos. An astronomer in the most distant galaxy we can detect would find themselves at the center of their own sphere, with their own horizon, seeing regions we never can, and missing some of what we see. Countless such spheres overlap across the universe, each one centered on whoever happens to be looking out from within it. So the deepest answer to how big the universe is may simply have no end. The part we can measure keeps growing, with every instrument and every age. But the part beyond our horizon may have no size that anyone could ever write down. Out here, the scale stops being a number and becomes something more like an open direction, leading gently away forever. And notice, in this most boundless of places, how little there is to fear. No edge rushes toward us. No wall waits to be struck. There is only room, endless and unhurried, opening softly in every direction, asking nothing of us, and leaving all the time in the world to rest within it. It takes a gentle effort of mind to accept that the edge of the observable universe is not the edge of the universe. We are so used to maps having borders and rooms having walls that the idea of a horizon without a wall behind it feels strange. But that is exactly what our horizon is. It marks the limit of the light that has reached us, and nothing more. Everything we can measure suggests that the universe simply continues past that limit, much the same as it is here. The same kinds of galaxies, the same web, the same smooth and even spread of matter, with no thinning and no boundary in sight. To suppose that it all stops precisely where our light gives out would be to place ourselves improbably at the very center of creation. And so the honest reckoning is that the whole universe is far larger than the part we see, hundreds of times larger at the least, and perhaps without any end at all. The portion we can map is enormous and still growing, and the portion beyond it may simply have no size that anyone could ever name. Out here, the scale stops being a quantity and becomes an open direction. Rest, for a moment, in the strangeness of being everywhere and nowhere, central at once. We sit at the middle of all we can see, and so does every other observer in the universe, each at the center of their own sphere of light, each seeing a slightly different portion of the whole. There is no true center to be found, only countless overlapping horizons and a universe that very likely continues, gently, past every one of them. This is the place where the scale becomes truly without bound, and where a person might expect to feel small or lost. But notice, instead, how quiet it is out here. There is no edge rushing toward us. There is no wall we will strike. There is only room, endless room, opening softly in every direction, with no demand that we ever reach the end of it. Part 13. The view that slowly closes. There is one last turn to the story of the growing universe, and it is the most reflective of all. Even as space expands without limit, the part of it we will ever be able to see is, in the slow language of cosmic time, gently closing. Both things are true at once. Because the expansion is accelerating, galaxies that are visible to us now will eventually be carried beyond the cosmic horizon. Their light will redshift further and further, growing dimmer and slower and redder, until at last it fades entirely from view. One by one, over spans of billions of years, the distant galaxies will slip away. Far enough into the future, an observer in our galaxy would look out and see only the merged remains of the local group, our own island of stars, gathered into a single great galaxy, alone in an apparently empty sky. The other galaxies will not have been destroyed. They will simply have receded past the reach of any light at all. There is a quiet wonder hidden in this, rather than a sorrow. It means that we are living in a privileged window of cosmic history. Right now, the whole grand structure is still visible. The web of galaxies, the most distant light, the faint afterglow of the beginning itself, all of it is still there for anyone who looks. A civilization arising in the far, far future, long after the distant galaxies have faded from view, would find the evidence already gone. They would see only their own island of stars, with darkness beyond, and they might believe that was all there ever was. The story of the expanding universe would be invisible to them. We, by contrast, have arrived at just the right moment to read that story in the sky. The light of 2 trillion galaxies still reaches us. The cosmic web is still open to our telescopes. The growing universe is still legible overhead for as long as anyone is here in this age to look up and measure it. There is a gentle paradox to rest in here at the end of the climb. Space itself grows without any limit, larger and faster with every passing eon. And yet the slice of it that we can ever touch with light slowly narrows. The universe enlarges, and our view of it will one day contract, and neither truth cancels the other. The final turn in tonight's story is the subtlest and the most quietly moving. We have seen that space grows without limit, faster and faster, opening endlessly outward. And yet the portion of it that we will ever be able to see is, in the slow language of cosmic time, gently closing. These two truths live side by side, and neither cancels the other. The cause is the acceleration we met earlier. Because the expansion speeds up, galaxies that are visible to us now are being carried over billions of years toward and eventually beyond the cosmic horizon. As they go, their light stretches further toward the red, growing dimmer and slower and cooler, until at last it thins away to nothing and they vanish from view. This will not happen quickly. It unfolds over spans of billions upon billions of years, far beyond any human reckoning. But it will happen. One by one, across unthinkable ages, the distant galaxies will redden and fade and slip past the edge of all possible seeing, until the far sky beyond our own island stands empty. Far enough into that future, an observer in our galaxy would look out and see only the merged remains of the local group, our own bound family of galaxies, long since settled into a single great island of stars, alone in an apparently empty sky. The other galaxies would not have been destroyed. They would simply have receded past the reach of any light. There is wonder in this, rather than sorrow, once you turn it the right way. It means that we are living in a privileged window of cosmic history. Right now, in this age, the whole grand structure is still visible. The web of galaxies, the most distant ancient light, the faint afterglow of the beginning itself, all of it is still here, still legible to anyone who looks. A civilization arising in that far future would find the evidence already gone. They would see only their own island of stars, with darkness beyond, and might reasonably conclude that this was all there ever was. The entire story of the expanding universe, so clear to us, would be erased from their sky, with no way left to read it. We, by a quiet accident of timing, have arrived at just the right moment. The light of 2 trillion galaxies still reaches us. The cosmic web is still open to our instruments. The growing universe is still written plainly overhead for as long as anyone is here, now, to look up and trace it. We are among the few who get to see the whole. So hold this gently at the end of the climb. Space itself grows without any limit, larger and faster with every passing eon. And yet the slice of it that we can ever touch with light slowly narrows. The universe enlarges, and our view of it will one day contract, and both are true, and both are simply the shape of a cosmos in motion. There is a tenderness to being born at the right moment to see the whole of it. Right now, the light of trillions of galaxies still reaches us. The web of cosmic structure is still legible, and the faint afterglow of the beginning still washes gently across the whole sky. All of it is open to anyone who looks, in this particular age of the universe, which will not last forever. Far enough into the future, that openness will quietly close. The accelerating expansion will carry the distant galaxies beyond reach, their light stretched away to nothing, until an observer would see only our own merged island of stars in an empty-seeming sky. The grand structure will still exist, but it will have receded past the reach of any light and so past the reach of any seeing. We hold, then, a rare and temporary gift, and the right response to it is not worry, but a kind of grateful attention. The universe has opened its whole story to us, for now, written plainly overhead. We need do nothing with it tonight, but know that it is there, immense and unhurried and complete, while we rest beneath it in our small and well-placed corner of time. So let the privilege of this moment be a quiet comfort rather than a weight. We happen to live in the age when the whole cosmos is still visible, when its light still reaches us, and its story can still be read overhead. That will not always be so, but it is so now, tonight, for as long as anyone cares to look, and there is nothing to do with such a gift, but receive it gently and let it be enough. This is not a loss to carry into the night. It is simply the shape of a universe in motion, immense and unhurried, opening and closing on timescales so long that no human heartbeat could ever feel them. The sky overhead is a rare and temporary gift, fully open now, and there is no need to do anything with it tonight, but let it be there, quietly, above you. Part 14. Why it never stops. We have climbed the whole ladder now, from the ground beneath you to the edge of the observable universe and gently beyond it. Before we let the night settle into sleep, let us draw the two threads together, the two kinds of growing that have run through everything we have seen. Our reach has grown. Sharper instruments and deeper understanding turned a single galaxy into trillions, pushed the nearest stars farther into the dark, resolved faint smudges into islands of light, and carried the edge of the known steadily outward. Each improvement made the visible universe larger than it had been the day before. And space itself has grown. It has stretched from the very beginning, carrying the galaxies apart, making the observable universe larger than its own age, and speeding up as it goes, so that the growing never slows and never settles. The distance between distant things increases with every second that passes, including this one. Across the entire history of looking up, the answer to how big the universe is has been revised many times. And every single revision has gone the same way. Outward, toward more distance, more galaxies, more time, more room. Not once, in all of that history, has the number shrunk. The cosmos has only ever turned out larger than we believed. The universe is large in a way that is unfinished, and this is the gentlest part of all. It is not unfinished because we have failed to measure it. It is unfinished because the measurement is genuinely, truly, still open. The growing is not a mistake waiting to be corrected. It is the most honest thing we know about the size of everything. And there is true rest in that, if you let yourself feel it. You do not have to hold the whole of the universe in your mind. You were never meant to reach its edge. There is no final number to carry, no boundary you are responsible for finding. The cosmos is large enough to keep unfolding for as long as anyone is here to watch it. It is large enough, too, to keep a small and quiet place for you, here, on this peppercorn of a world, in a calm suburb of an ordinary galaxy, in one bright bubble of an endless dark. The growing happens far away, on timescales beyond all worry, and it asks nothing of you tonight at all. The number will be larger tomorrow, and larger still long after this night is forgotten. There is no edge to arrive at, and no final figure to reach. There is only the slow, endless, gentle opening out of everything, going on quietly in every direction, whether or not anyone is watching. Look back, now, across the whole of the climb we have made tonight. We began on the ground beneath you, with the slow ruler of light. We passed the sun and the planets, the icy edge of the solar system, the nearest stars in their long loneliness. We measured our own galaxy and found ourselves living quietly off to one side of it. We watched the universe leap outward when the faint smudges resolved into galaxies, turning one island of stars into trillions. We drifted to Andromeda, the nearest great galaxy, and to the small bound family we belong to. We climbed through clusters and superclusters into the great cosmic web, and found most of the universe to be unseen. We learned that space itself is stretching, carrying the galaxies apart, and that the stretching makes the universe larger than its own age. We found that the growing is speeding up, driven by a dark energy woven into empty space, with no end anywhere in sight. And we stepped, at last, beyond our horizon, into a universe that may simply go on forever. Through all of it, the same two threads have run, side by side, the whole way out. Our reach has grown, turning blurs into galaxies and pushing the edge of the known steadily outward. And space itself has grown, opening and accelerating, making the cosmos larger than its age and larger with every passing second. And every revision, across the entire history of looking up, has gone the same way. Outward, toward more distance, more galaxies, more time, more room. Not once has the number ever shrunk. The universe has only ever turned out to be larger than we believed, and there is every reason to think it will do so again. The universe is large in a way that is unfinished, and that is the gentlest discovery of all. It is not unfinished because we have failed. It is unfinished because the measurement is genuinely, truly, still open, still climbing, still revealing more. The growing is not a flaw to be corrected. It is the most honest thing we know about the size of everything. And in that, there is a true and simple rest. You do not have to hold the whole of the universe in your mind. You were never meant to reach its edge, or to find its final number, or to carry the weight of all that distance. The cosmos is large enough to keep unfolding for as long as anyone is here, and gentle enough to let you close your eyes inside it. It is large enough, too, to keep a small and quiet place for you, here, on this peppercorn of a world, in a calm suburb of an ordinary galaxy, in one bright bubble of an endless dark. The growing happens far away, on timescales beyond all worry, asking nothing of you and leaving you free to rest. The number will be larger tomorrow, and larger still long after this night is forgotten. There is no edge to arrive at, and no final figure to reach. There is only the slow, endless, gentle opening out of everything, going on quietly in every direction, whether or not anyone is watching. If there is a single thread to carry out of tonight, let it be this. The universe has only ever turned out larger than we believed, never smaller, in every age of looking. That is not a story of confusion or error. It is a story of a cosmos generous enough to keep exceeding our largest pictures of it, again and again, with more distance and more light and more room. And the right feeling to meet that with is not vertigo, but ease. We are very small, and the universe is without end, and far from being a frightening thought that turns out to be a freeing one. Nothing so immense in its growing asks anything of us. It simply continues, gently and endlessly, and leaves us free to rest within it, exactly where we are. So let the great opening out go on, far away, as it always has and always will. Let the number keep climbing in the night, past every figure anyone could write. You do not have to follow it any further now. You have come to the edge of what can be seen and found, instead of a wall, only room and quiet, and the long soft dark in which it is safe to close your eyes. And perhaps that is the truest comfort the scale of the universe has to offer. We are not asked to measure it, or to master it, or to reach its edge. We are asked only to belong within it, briefly and gently, on this small world, beneath a sky that goes on without end. The universe is large enough to hold every question and ask none of them back, and quiet enough, tonight, to let you set yours down and rest. It has been growing since long before you arrived, and it will go on growing long after, and in all that growing it has left, just here, a small and gentle place for you to close your eyes. And so we leave the universe where we found it, larger than when we began, and larger still by the time these words are done. There is no edge to reach tonight, and nothing out there you need to hold. Let the great slow opening out go on without you for a while. Let your breathing slow. Let your thoughts grow quiet and far away. Sleep well, and good night.